All right, let's get started. Okay, number 72. I like number 72.
You like all of these.
That's kind of true. I like number 72 especially because it gives you some information you never even need. And I love to do that.
That's totally something you would do.
Absolutely. So number 72 reads, your family just had a new refrigerator delivered. The delivery man has left and you realize that the refrigerator is not quite in the right position. So you plan to move it several centimeters. If the refrigerator... Yeah, I'm happy I'm not an English teacher too. If the refrigerator has a mass of 88 kilograms, the coefficient of kinetic friction between the bottom of the refrigerator and the floor is 0.13.
Homerooms 93 and 94, they can report to the library.
How are you feeling, Mr. Gray?
And the static coefficient of friction between these same surfaces is 0.21. How hard do you have to push horizontally to get the refrigerator to start moving?
I'm guessing we need the static and the mass.
I
don't need the other part.
You do not need the kinetic coefficient. You are correct.
Good, because I didn't know what that was anyways. Wait, is that the kinetic friction? Oh. Oh, never mind. I didn't know what that was.
Remember, kinetic friction is when something's moving. Static friction is when it's not. You have to overcome that the static friction force to get it to start moving. So, you don't need the kinetic, where's that? The coefficient of kinetic friction between the bottom of the refrigerator and the floor to be 0.13. That's pointless information thrown at you just to tie you up and trick you. Will I do that?
Yeah.
Absolutely.
Tied up in here right now. We're hostage.
Whatever.
Free us. Free us.
It's like on the news, you see this video.
What's hostage teacher like students up in here?
God help us. Okay, so here's what we got. We got a floor. My floor. Here's my refrigerator.
What's the slope of that? Right there.
Don't know. You broke it.
I know I didn't.
Alright, so here's the refrigerator. And I'm trying to apply a force that will make it move. So this is what I got to find out. What force do I have to push the refrigerator with? Only thing I got to find in this case is the other force going in the back direction. What comes opposite of the motion?
0.21.
That's the coefficient. That's not the force of friction. It's the force of friction and static
We need
friction.
link strips 95 and 96 to report to the library.
The what?
That's the static friction force.
So that's what's pushing.
I spell it out static.
I'm gonna drop
Can you put FS?
it.
Bet you could. I put F sub S. That's fine. So, force of static friction. I have to overcome that. What is the equation for force of static friction?
Gosh.
The force that.
Mu S, I guess is what it is.
Okay.
F-N. F little N.
Capital little N.
F little capital N.
Okay, this is how we'd say it. Okay, static friction force is less than or equal to the static friction coefficient times the normal force, which is F sub capital N.
So is that important to know like those words?
You don't need to be able to say it how I said it, but
Okay.
you need to know in this case what information do you need. We're trying to find the static friction force. Do you have the coefficient of static friction between the floor and the refrigerator?
I guess it's your 88 kilograms, but I don't know. 'Cause it's pushing.
Going back to the question, the static coefficient of friction between these same surfaces is 0.21. So do we have that?
Yes.
Yes.
Yeah.
Do we have the normal force?
Yes.
No.
No, we don't have it.
Can we calculate it?
Yes.
No.
Yes.
Kinda.
Why? Okay. What forces are acting on the refrigerator?
Gravity.
Force of gravity.
And 88 kilograms.
Gosh, I was great.
Gravity.
Okay. And what else?
Your,
Natural force.
What
Normal force.
What is your normal force?
force.
Normal force is the force that is perpendicular to our surface.
Wouldn't that be natural though?
What is that though? What is it?
But it's,
Okay, it's just like the opposing force of
Is it a
gravity.
set
it
number?
could be a natural
One.
force.
No, you can calculate it. Okay, is the refrigerator falling through the floor?
Like it was-
No.
Is the refrigerator jumping up into the air?
I'd like to see that.
That'd be cool, wouldn't it? But no, it's not, is it?
No.
Okay, so these two are what? I've said this 1,000 times in this class.
Equal magnitude, opposite direction.
Equal in magnitude and opposite direction. So for us to find this, we just got to find force of sub G, which is just the force of gravity, which is weight. Now, I'm going to do this just because I like dealing with positive numbers in the end. I'm going to make up as positive, down as negative. So what does that mean?
Gravity's negative.
Gravity is negative 9.81 meters per second squared. So before we can ever solve this, we're going to have to solve and find weight, which is force of sub G, which is equal to mass times gravity. Do we have mass?
Yes.
What is our mass?
88 kilograms.
88.
88 kilograms. That's a good thing. Remember, tomorrow on your quiz, Mr. Hall is evil enough to put metric conversions inside of your questions.
Do we
I
need to use
wanna
our
go
chart?
to sleep tonight.
No!
So we got to know this?
Yes! So, what we get? Mass is 88 kilograms
You're amazing. Alright.
times negative 9.81 meters per second squared. You're going to punch that in your handy dandy calculator.
I ain't got it.
You got one right there.
Negative 863.28.
So negative 863.28 what?
Nope.
Newtons.
Woo.
What's a Newton equal to? I want to do this just to see. See if you can tell me. Unit wise, Newton equals what?
Kilogram.
Meters per second squared.
Over second squared.
I just want to make sure. Newton equals kilogram times meter
Like
all
a
over
lunch.
second squared.
Are we gonna need that tomorrow?
Definitely.
You're definitely going to try to trick
Let
us
me
out.
All
write this down. Let me.
is fair game. Once you learn it, don't forget it. So,
If I didn't
this
know
is
better, like I said,
the normal force is equal to the force of gravity, but opposite direction. So it is 863.28 newtons.
That's our normal force. Why do you do F sub G? Why?
I don't.
What does that mean?
It's the force of gravity. That's weight.
It's like the natural force, but gravity.
I didn't like that 8.
I could say a lot about some of your numbers.
You shut up, man.
Hope the people on YouTube follow your numbers.
If you ain't from Southern West Virginia, don't watch these videos.
Hey, I'm doing this for y'all. I don't care what they think.
Ignore the haters.
Okay, now, do I have everything I need to solve?
Yes.
Yes.
Wait, I have a question.
Yeah,
Why is it positive there? Oh, it's
because
going
I
up?
made the positive up so that I could have a positive number to deal with.
Okay.
What is MS? What is that?
That's mu sub s.
It's what?
And that's the coefficient of static friction.
Okay.
So in this case, force of static friction is less than or equal to coefficient of static friction from the problem was 0.21, and it's going to be times the normal force, which we found to be 863.28 newtons. And that'll be less than or equal to, what you calculate.
The US is the coefficient of
Lost
friction.
me, buddy.
Coefficient.
So do they not have a unit?
So what is the F?
No, it doesn't.
Okay.
Okay.
It's
It doesn't.
friction static or whatever.
Do what?
Force static. Okay, I'm fine.
Okay, so we'll find that the force of static friction is less than or equal to 181.288 newtons. Ooh. So, what force do you have to apply to overcome the force of friction? To get the refrigerator moved, you must push with a horizontal force
I'm greater than
greater than
that.
181.288 newtons. Okay, so a force greater than 181.288.
I don't feel confident about this quiz.
Me either.
Okay. What's your questions here?
I think
Well, we gotta know how to do the
them.
problems we did last week too. Cause it's like a double.
And problems you did on day 1, day 2, and day 3.
Oh my gosh, I'm
I'm
so.
gonna have to I'm gonna just relearn the
Should be like on the
formula.
stuff you go over, not in the first week.
But I went over that, so it's actually what you
Yeah, we
said.
took a quiz on that already.
So let's hold up here because we're still recording. Are there questions here?
I'm so all aboard.
Okay, so what was we trying to find?
It's a statement, not a question. What you're trying to find is what force we have to push the refrigerator with to make it move.
And we found that by taking the normal force times the coefficient static.
The static friction, yes. Because you have to overcome that static
Yeah,
friction. Once
That makes
it's,
sense.
we'll look at it one day, like I'll show you a graph of what it looks like, but it's kind of like like static friction, you keep going up, 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 and then when it starts moving, it like spikes down, and the force of friction is constant.
Are we eventually gonna get to where like we figure it out with different surfaces under it?
But I'll always have to give you this coefficient. I'll always have to give you this number. I do not expect you to remember a list of these.
At least of them.
Yeah, I will give you. Because for every surface it's different. Like if I had a rubber box on this tile, and then I had a wooden box on this tile, it's
Right.
different forces.
Okay.
Friction coefficients, I mean, sorry.
Is this all the problems we're doing? Or all we're recording?
It's all that I'm recording.
And that's
Bye,
the
you
tape.
two.